Hello, can you hear me?
Yes, I can
Yes,
hear
I can.
you.
Okay, so hope you are well. Okay, so
Yeah, I'm okay.
basically today we will try to discuss about that how we can easily make for LST or NDVI time series chart for different land cover classes. Suppose you want
Yes,
to for the cropland, what is the condition of the LST? For that NDVI, what is the condition of the cropland? What's the NDVI? You want to check the time series chart. So this type of analysis today we will try to discuss and also try to solve you practical problem how we can easily do that. Okay, so let's
yes,
go.
sir.
Just I simply share my screen. Okay, so now can you see my screen?
Yeah, it's coming.
So basically here I already write quick code about that Bangladesh
Okay.
boundary. In this code, we are just showing that for this specific land cover classes, such as what is the condition of the NDVI only for the cropland for the different time period, as well as what is the condition of the land surface temperature for that cropland for the different time period. So here you can see two types of result we can got in here. So first it's showing the result about that NDVI mean different time yearly. Okay, we can get the dataset yearly. So for that
Mm.
it's mainly showing the result for the cropland. For the cropland, what is the condition of the NDVI for the different time period. Okay, as well as also you can see it also showing the another thing is that for that land surface temperature, what is the condition for the land surface temperature for specific classes for the different time period. Okay, so this type of chart we can easily create for a specific, because in this time we can get the data for 2019, we can get the data 2019 for the land cover of cropland classes, 2020, also 2021, also 2022 for that land cover class of cropland. Okay, same process also you can see for that okay, so this is the land surface temperature monitoring for the specific classes. Okay, different time period. Okay, this is the one process. Another process also you can see that this is the another way. So basically this is the classification. In this classification we mainly classified such as build up area. Red color identify the build up area, then yellow color identify barren land, then blue color identify the blue water, and also the green color identify the vegetation or forest. Okay, so now you want to check what is the condition of the NDVI for the forest for the different time. Okay, so for that we can easily create that. You can see, just I simply click on here. I will explain the code later. First of all, I try to show you the output. So here you can see mainly this time series chart showing the result about that different time period only for the forest or vegetation. What is the condition of the NDVI for the different time period only for the one specific class such as forest. Okay. So also you can see the another thing is that, so basically another thing is that it also showing the about the land surface temperature for the different places. Okay, so water, mangrove, and residential slum, airportic thumbs. Okay, so different region, what is the condition of the land surface temperature. Okay, for the water you can see very low temperature. Okay, for the airport thumb with this region you can get the high temperature about that. Okay, as well as also you can see. Okay, so this is the your tax. I already write about the code for the LST. Suppose a specific class, what the for this specific class you already classified this your region. You can see this is a classified map. So in this
Yeah.
classified map you want to just showing what is the condition for the cropland for the LST, what is the condition of the NDVI. Okay, so let's go about that. All of this code I try to explain one by one, then I hope you can easily learn about that. Okay, so first code
Okay.
you can see mainly this code. First of all we need to take the image collection. In this time we are not applying the supervised classification. Okay, we are just taking the data set from here. Okay, basically it is our data set. This data set provide you the land use land cover data set 10-meter resolution. Okay, you can see this data set. We can get the data set from here, the land use land cover classification for the 10-meter. As well as also you can see mainly it classified this type of class such as tree cover, shrubland, also grassland, cropland, okay, also build up area, barrier, snow and ice, permanent water bodies, herbacées, wetland, mangrove, moss and lichen. So this type of class we can classify it from this data set. Okay, so in this time, first of all, what can I do? I just simply import this image collection in here, okay, and take the first image, okay, and after that I also need to make the collection of the NDVI, okay, because I can get the land use land cover image and I also need the NDVI collection because I want to observe the NDVI for specific classes from this image collection. Okay, so for that what can I do? I can simply take the image collection such as Modis NDVI image collection. So just you can see this image collection about the Modis NDVI image collection, what it will be work. This is the Modis image collection. At mainly it provide the NDVI band and also EVI band. Okay, so two types of we work for the NDVI. Okay, so for that I simply import my image collection and then which year I want to need. I need for the year of 2019 from 2019 May. Okay, so I simply filter my specific time period. Okay, this time you can see this is my specific time period. I need this data about this time period, also need this about this time period, also need this about this time period, also need this about this time period. Okay, and then I filter bounds with my region of interest variable name. Okay, so then also you can select the NDVI band. Okay, so now I simply get the data set from the Modis image collection. Okay, and filter all of those data and select the specific band. After that, what can I do? I can simply reproject it, this scale value. Okay, so for the reprojected, what can we do? Just simply multiply with our scale factor. Okay, and then you can see here we are also need to put here this value 40. In this time, what is the 40? 40 is the value of cropland, because in this time from this LULC data I need only for the cropland. Other data set I don't need. Okay, I need only for the cropland. You can check the data set about that land use land cover data set. Here you can easily find out what is the value for the cropland. You can see they're already classified because this is the ready-made data set. We already classified about that. You can see for the cropland, what is the value for the cropland? Cropland value, you can see cropland value is the 40. Okay, and I want to observe for the NDVI and LST time series only for the cropland, not other classes. Okay, so that's why I can simply put here the equal to 40. Okay, you can see I will put LULC equal to 40. Okay, and click with my shapefile. Okay, so after suppose you want to need the build up area, then you can simply change the value. Then you can get the map for the build up area and also get about the time series chart for the build up area. Okay, so after that what can we do? Just simply use here the copy properties and put here this all of the things, and then simply call this NDVI collection. You can see NDVI collection. I already created the NDVI collection. This NDVI collection I just add with my function here I created. This function I just simply add with my NDVI collection. Okay, using the map function, simply add that. Okay, so after that I can simply use here this NDVI bands reduce regions function. So put here this, you can see reduce region function. Okay, then put here this NDVI calculation, all of the things you can create it. And as well as in this code I also add here another thing is that for this time series chart as a Excel file. Okay, you can see it also provide the Excel file about that. So that's why I also write the code for the Excel file. Simply click to here this all of those time series data export as a export Excel file or CSV file for LST and NDVI. Okay, as well as also you can see you can simply show the results. So that's why we can simply write the code, and then we can also add this type of map. Okay, and finally we also try to show the result in the time series chart. For that we are using the function UI chart image doi series by year. Okay, then in NDVI collection final, okay, which I already created. You can see this variable name I already created in here. For this you can see in this I already created about that. Okay, so I simply call them and then paste in here NDVI final collection. Okay, so put here this argument is that like that, and then NDVI is my band name, then put my region name, E reducer mean, all of them will be same. Okay, then I can simply print that, then I can get the result about the time series chart of NDVI look like that. Okay, so now it represented about the time series chart only for the cropland. Okay, whole country boundary Bangladesh where I can get the cropland, it's showing the result about the cropland. Okay, different time period, which time period I want to select it in here. After that LST, in this time we are just using here the Modis land LST, and modis LST same time period. We can also select the same time period, okay, all of the time period, and simply select the band of the LST day 1 kilometer. And this band we also need to reproject it, okay, just multiply with the 0.2 for reprojected and subtract with 270 30.15 for convert the Kelvin to degree Celsius. Okay, so after that we can simply make the collection also for that same process, all of the things, okay, and we are also add the code for directly download the CSV file format from here. And finally we are also just showing the image of the LST, as well as we also display the result as a chart, okay, just we can simply use the collection of the LST and all of the thing will be same. Now it represented about that LST time series chart. Okay, so now using this same code you can easily create, just you need to change here this class 40 is the fixed for this cropland. Okay, you can see for this data set it's showing the 40 is the cropland, but you want to need for the suppose other types of areas. Suppose you want to need the result for the build up area. Suppose in this time I want to make the time series set for the build up area. So what can I do? I simply copy the 50 and then simply paste here the 50. Okay, so now I can get the result about that build up area for Bangladesh. What is the condition of the NDVI and LST only for the build up area region? Okay, so
Sorry, so this image, sorry, the function image where you wrote the is line number 14.
Yes, you can see in
On
this
the
time, yeah,
IMG, where is the image from? Or is
this
just
image come from, you can see this image come from this image collection. In this you can see this image collection LULC. In this variable already stored all of those classes is stored in here. Okay, you can say I simply use the LULC then equal to class value. Okay, equal to class values. LULC stored my all of those classification image, and from that I simply set equal to 50. 50 means that build up area. So now I can get what is the condition of the build up area. You can see NDVI, I can easily get the result, as well as what is the condition of the build up area. Okay, we can easily get the LST result also. Okay, and this result come from the modis. Okay, if you want you can also use here the Landsat image also. Okay, so this is the process for the modis, NDVI and LST, how we can easily show the result for the different land use land cover classes. Okay, and this land use land cover class is ready-made dataset. We can get the dataset from here. Okay, and I think you are also use the dataset also in here. His image you can send me that. You can see you are also send me this image collection in here, but you are also comparing the result using the Landsat image for checking the accuracy assessment. For checking the accuracy assessment, you are also using here the Landsat imagery. Okay, there is no problem. We can easily do that. There is no problem. You can see in this image collection. For you can see you can use this image collection ESA wall cover, okay, and mosaic it and also use it. And also you can see this type of 10 20, okay, this type of class value, okay, class value. Suppose 10 is represented one class, okay, so this type of class value you just remap or reclassification from 1 to 11. So in this time 10 is 1, then 20 is 2, then 30 is 3, 40 is 4, 50 is 5, 60 is 7, 70 is 8. So this type of we can make the remap, okay, or you can see remap function. Okay, just we can class value and also remap values. Okay, so when I use this value, then 10 will be 1, okay, 20 will be 2, then 30 will be 3, 40 will be 4, 50 will be 5, 60 will be 7. Okay, so thus we can remap or reclassification about that. Okay, so then okay, I will write about the code for this. Okay, so you can see this type of process we can also do. But in this time we will also add here the another thing in this code for the Landsat imagery for check the accuracy. What the accuracy we can got? We can just similar. Suppose one data set we can get from here, and another data set we are also extract the data from that Landsat imagery. Okay, you can see in this data set you can see number of points. So randomly we can get from this Landsat image randomly get the 10,000 point. Randomly we can take this 10,000 point. This is our training data set. Okay, this training data set we are just simply divided the 80% data for train our model and 20% data for check our validation. Okay, so after that we can simply import all of the things for our number of days. Okay, same all of the things, then classify our result, and finally we can check our validation about the result. About that you can see the validation of this map is that 99% accuracy we can get about that. Okay, so this data set we are using in here, this data set accuracy is the 99%. This data set ES world cover. Okay, we can compare this data set with Landsat imagery using 10,000 training point randomly. Okay, and we can check that
Okay.
accuracy is very good, there is no problem. And after that you can see, okay, we can use here this random forest classifier. Okay, and then train our model and classify this image and also check the accuracy assessment. Okay, so now I want to check about the result. What is the condition about that, suppose, and also calculated the area. All of the things will be done for this region. You can see now you need to calculate the area. What is that? Suppose class 4. What is that chart about the NDVI for the class 4? I want to observe it for this region. Okay, so before that I also try to discuss about my another code, then it will show up with also. So this code is only for the NDVI and LST from the modis for the different types of land use land cover classes. I also send you about the code. Another code you can see,
Okay.
yeah, this code you can see. This code mainly we are make here the supervised classification and classified the water body, build up area, then barren land and vegetation, and we can get that 85 accuracy. So now suppose you want to observe what is the condition of the NDVI for the cropland. You want to check about using the time series chart. So what can we do? After classification you can see classified, mainly this variable stored my image. You can see when I want to map.add layer function, you can see map.add layer function and call the classified, then this image display. Okay, so this classified, this variable stored all of those classes. Okay, build up area, you can see how much class I want to add in here. So it had the water body, urban, vegetation, and build barren land. Okay, so all of those class will be stored in this variable classified. So what can I do? I can simply take a variable. You can see, suppose I take about that, suppose you can see this is the 0, and also you can see this is the 1. Okay, so in this time because I will not take the class for the supervised classification for from your base, so that's why you are not understand about this part, I think. Okay, and I also take the class after Idul Adha, after the 1st July, then I hope you can easily understand about that, how can you take about that. So in this time you can just remember that water is the 0, urban is that 1, vegetation is the 3, barren land is the 4 number of class. So in this time, so I want to work for the vegetation. So you can see what is the vegetation number. Vegetation number is the 2. Okay, value is the 2. So that's why I simply put here this value classified equal to 2. Mainly 2 is the class of vegetation. Okay, you can see vegetation. Okay, so I simply select the vegetation. So now what can I do? This vegetation, I want to show the vegetation as a, mainly you can see vegetation is showing as a raster image. Okay, this raster I convert as a vector. Okay, so for that what can I do? I simply take a variable vegetation and classify it. Mainly it stored all of those classes. From all of those classes I just select only for the vegetation value 2. And the vegetation is the 2, barren land, you can see what is the barren land. Barren land is the 3. Okay, so all of those class has the individual value. Water is 0, urban is, you can say urban is 1. Okay, so in this time I want to work for the vegetation, so just I simply put the 2. After that I take a variable veg and classify update marks with the vegetation. Okay, and use a function reduce to vector. So mainly this function convert the raster into vector. Reduce vector, this function convert raster into vector. So then I simply put here the geometry is my shapefile variable name ROI. You can see I already imported the ROI in here. ROI, my shapefile variable name ROI, and then put here about this result. Scale is the 30 meter. And when I suppose I want to show the result, suppose I want to show the green color as a vegetation. Okay, so in this time when I click to the run, you can see it added a new layer about that. In this time I separate only for the vegetation map. Okay, you can see, and this vegetation map I also convert into raster to vector. Okay, it will be later, you can see. So you can see. Yes, this is my vegetation map. Okay, only vegetation, it's showing only for the vegetation map. There is the no other classes. Okay, other class showing as a gray color. Okay, it now showing only for the vegetation. Okay, So now I just convert this area. Suppose this vegetation area I want to convert into vector or polygon. Okay, so this type of vegetation I convert into polygon. So for that you can say I simply added the another layer. So now all of those vegetation convert into polygon, you can see, okay, as a vector. Okay, so now it's considered as the area, not raster. Okay, so this layer 4 stored the data as a vector. Okay, so you can see I just simply separate and make the raster to vector conversion. Okay, so now this is my area. So now I want to just make the time series chart of the NDVI using this vector area which I get from the vegetation raster image. Okay, so for that what can I do? You can see just I simply add a NDVI band and NDVI use the normalized difference function, put here the near infrared band and red band. Okay, and also put here the calculate the NDVI. Okay, so after that I simply use the map function and connect the NDVI. So for that what can I do? Just I simply print the chart, you image the slide, and in this time what is my region? Region is my VEZ phase, because you can see this type of area, this area is stored in this variable. This area is stored in this variable. Okay, it's my vector area of vegetation. Okay, and I want to observe the NDVI only for the vegetation. So that's why I simply convert the all of those vegetation raster image into vector and then get the result. Okay, then click to run. So now we can get the result about that, about the vegetation. Okay, so it's the another problem is that you can show the user memory limit exists. Okay, so in this time there are a lot of pixel value for the vegetation. So sometimes it's not work for the chart. Okay, so you can see here. So in this time, okay, so I also do for the another thing is that suppose I want to increasing the scale value and then check the result again. So just I simply put here the scale value, suppose 1000, and can click to the icon because there are a lot of pixel value and it exists the limit of our time series chart. Okay, so now we can check the result about that. Okay, just we can simply convert raster into vector. Okay, so basically it's a polygon. All of those polygon we can get the result in here, you can see. So it's also not working. There are a lot of pixel value for the vegetation and a lot of big area. Okay, that for the big area we are also applying this method for starting the data in Excel file. You can see I already write the code in here. You can see Excel file. Okay, so then it will be easily exported from the Excel file. Okay, just we try to check the another class. Suppose I want to show the class for the water body and then check what is the chart evaluated. So for the changing this class, what can we do? Just I can simply put here this class value. Class 2 is for vegetation. Okay, so 1 is the urban, 0 is the water. So I want to show the 0. So put here the 0. Now it show the result for the water body. So just what can I do? I simply suppose water body, I want to show the water body as a blue color and then click to the run. So now we can easily from this image we can get the water body map, and this water body map also convert into vector. You can see only for the water body. Okay, so now this type of water body convert into vector, and then finally we can also get the result in the time series chart above the NDVI for the water body. Okay, suppose I have to check about that urban. So 0 1 urban is the one number of class. So just I simply put here that 1. Okay, so you can see classified equal to 1. So now I can get the result only for the urban, and I also change the color about the urban. Suppose I want to show the urban color as a red color, so put here the red. So in this time this map also display the urban map as well as also make the time series chart for the urban. You can see in this time it only showing the urban area. Okay, yes, the urban area. You can see, yeah.
So there are two ways. I can have it as a raster and also I can convert it to vector.
Vector, yeah. Then this vector will be work as the region. You can see now I convert is a region. So now when I want to make this time series chart, then this time series chart will be work only for this region. Okay, and show me the result about the NDVI or NDWI or LST. Then I can get the result only for the urban or build up area. So now I can see it will be appeared in here. You can get this data about that. So now I come back to your code, which code you can send me. So your code, I already check about that. This code, all of the things will be done. This is your study area, and we can just use here the map centered object for focusing the center, and then we are also use here the Landsat top of atmospheric image collection, and also get the mean, median, composite for this. Okay, and then we are also just Landsat image that clip with our boundary and scale. That put that we are take all of those band value. Okay, and also input land bands, and also use this image collection because basically land use land cover classification map created from here. Okay, created from here, and we are also use this type of Landsat image for accuracy assessment about that map. Okay, so for that we can see mosaic, and also you can see this type of class 10 to 100. It individually class it, you can see if you want to check about that, all of those class you can also get in here. So 10 is the tree cover, subland, grassland, cropland. Okay, this type of class. Okay, so in this time 10 to 100 we convert to 1 to 11. Okay, so 10 will be 1. Okay, so just you can simply use the remap function and then change the value. Okay, so now 10 is 1, 20 is 2, 30 is 3. Okay, this type of value you can change. After that you can see for the Landsat image, from the Landsat image you can see I already defined the Landsat image in a variable, and in this variable stored the all of those Landsat image in here. You can see the Landsat. Okay, this is my Landsat image. Okay, from this Landsat image I just select a band of LC. LC means that what is the LC? LC is the band of classification. LC means that your land use land cover data set. You can see LC. Okay, LC means that land use classification map. It's our label LC. Mainly it stored our all of those classes 10, 20, 30. Okay, and we also remap that, so it will be stored the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, and represented the different classes, and use a function stratified sample. So basically this function we are using for taking the data set, taking the data randomly. Suppose in this time we can get the 10,000 point from this image, from this Landsat image we can take the data for the 10,000 element. Okay, you can see about this image. Yeah, so this is our Landsat image. I also add the visualization, then it's also better showing about that. Suppose you had the B4, B3 and B2, and custom range 98% stress, and apply. So this Landsat image I just get the result. Okay, you can see this Landsat image we can just extract the 10,000 point. Okay, and then take the staining point, and this staining point we can simply separate. Okay, randomly 80% for 10-hour model and 20% data for test hour model. Okay, and this is our machine learning method, all of the things for the random forest classifier, and then classified this image and also accuracy check the accuracy. Okay, so after that what can I do? I just simply use here about that and this code for the area calculation. Okay, so this type of the code I also try to largely I describe in our next class about that. Then I hope you can learn about that all of the things, and then you can see in this time we can simply cropland. We work for the cropland. Okay, so you can say I use here the 4. Why I use the 4? Because you can see for this class bands, you can see 40 is the cropland. Okay, but we are considered this result as a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So in this time 40 will be 4. Okay, because we are remap it. So just I simply use the 4. Okay, and then what can I do? For just I simply classified in the 4. Okay, so okay, and showing the result. So after that I can simply use here this suppose 4 is the cropland or vegetation, anything you can write any variable and there is no problem. So I simply call my image collection and click with my study area and then equal to 4. Now it select only for the class 4 or cropland. Okay, this cropland I just simply convert into as a vector. Okay, raster to vector. So I also open another line of the code. You can see there. Okay, so now you can see we can get the result only for this region. Okay, and if you want to show the result about that, just we can convert this type of result, you can convert as a vector. This type of area we convert as a vector. Okay, and after that raster to vector calculation and show the result, and then we are calculating the LST from this LST. So basically LST, we can also calculate the LST also from the Landsat imagery. Okay, and this is the module. Okay, basically this module is that Landsat module, and it is stored the all of those Landsat function. This module is stored. So in this time, this module is stored all of those algorithm for the LST. And I already discussed about the LST, how you can easily create the LST. But in this time, all of this model is stored in only for the one line of code. Okay, just I simply call this model name and use the require function and put here this module user ID. Okay, and it publicly open, anyone can use it. This model, there's no problem. And then set parameter to this model. So we have set the parameter for the Landsat 8 and also put the time period look like that, 1 year time period. Use NDVI true. So basically this is the parameter. This parameter for this model. Okay, just we can simply put our parameter look like that, and then get Landsat collection added with the NDVI or FC, this type of EM. Okay, so this type of result we can add in here. Okay, so Landsat LST collection. So just I simply call the satellite and date start. Okay, date start end, use NDVI. So this type of argument or this type of parameter we can simply add in here. Okay, so after that we can select the LST band. So I can simply select the LST band, and this LST band showing the result as a Kelvin. So just I simply subtract with 273.15, then I can get the result degree Celsius. Okay, so after that we can simply put the time period look like that, and then I just simply click to the run. So it also showing the result about the LST for this region. And when I want to make the time series chart about this band, you can see okay, you can see this is my collection Landsat month of May. Okay, this time period, and this is my area. Okay, this area is mainly for that cropland. Okay, because it is stored in the region of the cropland. E reducer dot mean and put this time series look like that, then the chart will be appeared. Okay, so now it's showing this result about that LST in degree Celsius only for the specific classes. Okay, so basically this lot of way for showing this type of analysis for the specific classes, what is the condition of the LST or what is the condition of the NDVI. Okay, so we are easily find out from this land cover specific land cover classes. Okay, so I also send you this code, all of this code for you also try to practice and also get the result. And face any problem, just send me the code with your asset. Okay, then I can easily find out the problem and also try to help you. Okay.
Okay. Yeah, hey, that was fruitful. Thank you very much. Thank you,
Yeah.
thank you, thank
Okay,
you.
thank you.
Yeah,
Okay. Okay,
yeah.
so I'll
See
send
you
you,
in
also
the
check it, and face any problem anytime, just let me know. Also send me the code link, then I can easily find out the problem. Okay.
okay. You are saying the users what Landsat, what is it? I didn't get you clear. That users for Landsat when you
Yeah.
calculated LST.
Yeah, basically this it work for the Landsat image, it work for the LST, and this Landsat image we are directly use a module. Okay, you can see this
Mm.
module is mainly stored all of those algorithm. So that's why it
Oh.
shortage our code. Okay, so first time we
Mm.
also discuss about the land surface temperature, then we need a lot of process we need to done. But in this time, when you're using this type of, you can see this is the module. Okay, users,
Mm.
and basically this created for the Sophia Mida. He create this module and Landsat for that module, and it also used for the land surface temperature. Okay, basically this module, when you are using this directly in your code, then you don't need to use other types of parameter. Okay, so it
Oh.
all automatically calculated all of those things, and then you can simply set the parameter L8. You put your start date and end date for the LST monitoring, and also put here this NDVI use NDVI true. Okay, after that you can simply all of those collection, you can see I simply call this variable name and paste here, and these are the collection, and our collection is that satellite. Satellite is the L8. I already stored it in the satellite in here. Start date, in date I already defined. Okay. Also you can see this is my region. Okay. And also you can see the use NDVI. Okay. So this type of parameter when you fill up, then it able to create a band about the LST. So that I simply call this variable name and paste here and select the LST band. And this LST is mainly showing the result as a Kelvin. So that's why I simply use here the just simply subtract with this value. Then it will be result as a degree Celsius. So now it is stored in here, all of the things in here. So just I simply make the collection about that and also display the result about the LST. Okay. So now
Okay.
showing the
Okay.
result and click with my shapefile, then we can easily get this result. And also make the time series chart. For the making the time series chart, which class I want to need, this class I just simply convert from raster to vector, and then vector will be work as a region. So just I simply use a region. You can see UI chart image of series. I put the collection. Okay. Then put here this region variable name, and all of them will be same. Then it will be work. Okay.
Yeah, I get.
Okay, so I also send you this practice code. So you also try to practice and face any problem getting any issue. Just send me the code link. Okay, so thank you.
Thank you very much. Thank you.
Okay, thank you. Have a good day. Okay, bye.
Okay, bye.